Hi guys, tonight we're going to take a look at how to find a quadratic regression on the calculator. We've learned how to find a linear regression, we've done that, or a linear equation, an exponential regression for a set of data, and tonight we're going to take a look at how do we find a quadratic regression or a quadratic equation for a set of data. So make sure you have with you the quadratic regression notes sheet, the graphing calculator reference sheet, and your calculator. And I'm going to refer to the different steps on this calculator throughout the video, but this picture, this graphic is not going to be up. We're going to use these directions to answer questions 1 and 2 on the second side of your notes sheet. So first we're going to take a look at question 1. The table below shows the height of a column of water as it drains from its container. X is our elapsed time in seconds, and Y is our water level measured in millimeters. We need to model the data with a quadratic function, meaning we need a quadratic equation to model this data. Then we're going to use that equation to estimate the water level at 35 seconds. So make sure you have your calculator. And if you haven't cleared it from class, then go ahead and clear it from class because the window range might be off. So turn your calculator on. We're going to hit Stat, and this is step 1 on your notes sheet, the calculator, graphing calculator reference sheet, and then enter, and then we're going to enter our X values in list 1 and our Y values in list 2, and I've already done that. So in the X list, I've entered the elapsed time in seconds, and in the Y list, or list 2, I've entered the water level in millimeters. So at this point, you might want to go ahead and pause the video to enter that data into your calculator. So now I'm going to go and turn on my scatter plot. So this is step 3. I will come back to step 2 because I want to see what this data looks like. So second and Y equals, and then we're going to hit enter twice to turn on our scatter plot. And if I hit graph, I don't see anything. So I'm going to hit zoom 9, and there's my scatter plot. And the calculator has already adjusted the window for me. But if you look at step 2 on your calculator reference sheet, it tells you how to adjust your window. And I know we spent some time in class on Thursday adjusting our window ranges. So we graphed, we saw the scatter plot. So now we want to look at this and see, okay, I want to find the quadratic regression or an equation in quadratic form that's going to model this set of data. So to do that, just like we did with the linear or exponential regression, we're going to hit Stat again, arrow over to Calc, and this time I want number 5, which is a quadratic regression. So you can type number 5 or just arrow down and hit enter. And on your calculator, because if the newer operating system, you might have to enter several times. But here is my equation. So here is a standard form of a quadratic equation, y equals ax squared plus bx plus c. My a term is 0.008. My b term is negative 2.07. And my C term is 121.19. Now at this point, you might be tempted to okay, so as I was saying, at this point you might be tempted to just round those to the nearest hundredth, to the nearest tenth. But we're going to jump down to step 5 on your notes, because if we round it, it's going to affect the data that our equation gives us when we put in the value for x. So step 6 on your graphing calculator reference sheet, we are going to find the Y vars, or the vars button. So we're going to press Y equals, and then this vars button right here. This is going to allow us to put that information in the equation. And then we're going to choose number 5, statistics, and then we're going to arrow over to EQ. And then we're going to hit enter. And there's the equation plugged in there for me. And now when I hit graph, there's my linear regression. No, sorry, there's my quadratic regression. So we're going to use this equation, because now it's in our y equals, to answer question number 1. Model the data with a quadratic function. Well, we've done that already. Here's our quadratic function. It's y equals ax squared plus bx plus c. So I have rounded just for room on my computer monitor. And I put in the equation y equals 9 thousandths x squared minus 2 and 10 hundredths plus 120 and 333 thousandths. So we're going to use this model to estimate the water level at 35 seconds. So again, we'll go back to our calculator. So what I want to know when x equals 35 seconds, because that's what our x value is measuring, what is y? So I'm going to go to second and graph. I can arrow all the way down to 35 if I want to, or I can just hit, second and window, and I want my table to start at 35. And then when I hit second and graph, at 35 seconds, the water level is 58.232 millimeters. Okay, now we want to find out, use this model to estimate the water level at 35 seconds. So back to our calculator, we should have our equation in the y equals, and we do. And if you notice here, I rounded my equation. And so if I go to 35 seconds, because that's when x is 35, so when I go to second and graph to look at my table, I want to go down to 35, but I don't want to arrow down all that way, there'd be too much clicking, so I'm going to do second and window, and table starts at 35. So now my table starts at 35, so at 35 seconds the water level is 58.232 thousandths of a millimeter. So when I found my answer for this one, I'll show you, at 35 seconds, I got 57.937 thousandths of a millimeter. I used this rounded version, so my number is slightly smaller than what was on the calculator. So now we're going to take this table. The data shows how a hairstylist's weekly profit is related to the price per haircut. So the price per haircut is our x value, the weekly profit is our y value. So we're going to do the same thing, go to our calculator, stat and enter, and I've entered the data already. So in list 1 is my price per haircut, and in list 2 is my weekly profit. So now we want to find the exponential regression, the quadratic regression for this data. So my calculator turned off. So again, we're going to go to stat, arrow over to calc. We want the quadratic regression, which is number 5. Hit enter twice. Gives us the A value, the B value, and the C value. We want to put this into our y equals. So back down to step number 6 on your calculator reference sheet. We're going to go to y equals, hit the vars button, go down to number 5, statistics, arrow over to equation, and then hit enter twice. And so it automatically puts our equation in there for us. So if we have really big numbers like the last one, those numbers will transfer in for us. So if I hit zoom 9, there is our scatter plot. Those are the little boxes in our quadratic regression, and it fits perfectly. So now we need to answer some questions. Observe that if the stylist charges too much for the haircut, the profit starts to decrease, and we can see it in the table here, and we can see it in the graph right here. And so explain why this occurs. Well, this occurs because profits decrease because customers don't want to spend a lot of money on a haircut. So as the price of the haircut increases, the number of customers is fewer. Question B we've already done. There's our quadratic model, negative 15x squared plus 435x minus 2,310. Letter C, we're going to use this model to estimate the weekly profit if the stylist charges $17 per haircut. So back to our calculator, and we'll go to second and graph. And so we want to know when x is 17, what is the weekly profit going to be? And you can see here, if we were up at $35, we should be getting to negative numbers. So I want to start my window at 17, so second in window, 17, hit enter. And now if I go to second and graph, my table starts at 17. So if the stylist charges $17 for a haircut, the weekly profit is $750. If the stylist charges $22 for a haircut, shouldn't make any profit. So when x is 17, what is y? the weekly profit would be $750. Letter D, other than when charging $10 per haircut, at what price is the weekly profit $540? So back to our table, and we're looking to see when the Y value is $540. So we know from the question at $10 it's $540, and we're looking to see when Y1 is $540 again. So if we do that arrow down to here, at $19, the weekly profit is $540. And finally, question E, according to the model, what is the maximum possible weekly profit? How much should the stylist charge per haircut? So we're talking about maximum profit. So maximum means we're looking for the vertex. So once again, back to our calculator. Here's our graph. We are looking for the vertex. So second and trace, it's a maximum, number 4. We want to be to the left of the vertex. I'm going to hit yes. To the right of the vertex, and I'm going to hit yes. And let's do that again because we want the maximum, So left bound to my vertex is over here, enter. Right of my vertex is over here, enter. And we're asking the calculator to take a guess. And so when the haircut is $14.50, the maximum weekly profit for this hairstylist is $843.75. So the vertex is the price per haircut, Y is the weekly profit. So the vertex is $14.50. We'll give her a max weekly profit of $843.72. Okay, now it's your turn to answer some video questions. A man throws a ball off the top of a building. The table shows the height of the ball at different times. So here's our x values, here are our y values. Find the quadratic function to model this data. So use the steps on your calculator reference sheet to find the quadratic regression that matches this set of data. Once you've done that, use the model to estimate the height of the ball at 2.5 seconds. So is the seconds measuring x or is it measuring y? So it's measuring x, so when x is 2.5, I want to know what the height of the ball is. And please round your answer to the nearest tenth of a second. Make sure to answer or enter your questions in the Google form. Have a good night.